Hi everyone, today you are going to learn how to write and name ionic compounds that contain polyatomic ions. Last time I asked you to refer to the ion sheet. On one side are the monatomic ions, on the other side are polyatomic ions. You're going to have to use both sides of that page today to help you understand what ions you're going to be using to come up with your formula for the ionic compound. So what is a polyatomic ion? Basically, you're going to have a grouping of covalently bonded atoms, and that whole structure gained or lost electrons. If you notice on your polyatomic ion sheet, a lot of them do contain oxygen, which makes them called oxyanions. The endings, watch the endings, you're going to see things like ate, ATE, you'll see ite, ITE, but most of them are not going to have that "ide" ending, like hydroxide does, but that "ide" ending is for the monatomic ions. So be careful on what ending you write down. Is it "ide," "ite," or "ate"? So some examples of compounds that do have polyatomic ions. Nickel 2-phosphate, notice the ending ATE. That means polyatomic ion. This is called calcium hydroxide. This is iron chromate. Notice that these two have parentheses in them, and I'm going to walk you through how you determine whether the formula will need parentheses or not. Our first example today is between tin 4 and sulfate. So just like before, we're going to write down our ions. Tin 4, the 4 Roman numeral allows us to understand that it is a +4 charge on the tin. Sulfate is going to be in the second column on the polyatomic side. It is towards the bottom. Sulfate is an SO4 - 2. You're doing the same thing. You're going to be switching and dropping the superscripts. Again, we're not worried about those charges. And you may have to reduce those superscripts. So what's going to come down next to the tin? And what's going to come down next to the sulfate? Well, there's going to be a 2 next to the tin and a 4 next to the sulfate. Task next is, can we reduce it? You can only reduce what you wrote on those red lines. You can't touch the 4 that's part of the sulfate because that's part of the polyatomic ion. So does this need reduced? Can you reduce a 2 and a 4? Yes, you can, but don't touch the 4 on the sulfate. It reduces down to a 1 and a 2. Now we may or may not need parentheses around the polyatomic ion. How do you know? Take a look at what you have next to the sulfate ion. That's a 2. In math class, if you have something other than a 1, more than one grouping of something, you would put that in parentheses. You're going to do the same thing here. That means we have more than one grouping of the SO4 ion. We actually have 2 for every one tin. So we are going to put parentheses around the sulfate. And those parentheses will go into the formula when we write it. So we're going to write it as a formula. Again, remember we don't put those charges in anymore. So it's going to be 1 tin, which is SN, then parentheses, SO4, parenthesis, and a 2. We do not write ones. Now we need to name it. Starting with our cation, which is the metal, asking yourself, does it need the Roman numeral? For now, I'm going to keep putting up my little periodic table to show you where tin is located and whether or not tin needs a Roman numeral. It is in our area where we do need a Roman numeral. So yes, tin does need a Roman numeral, and the Roman numeral will be the original charge on the tin, which was a 4. Our sulfate never gets a Roman numeral, and the anion never does. So we're just going to name the anion. Remember, careful on the ending. This is a polyatomic ion. So this is going to be SO4. It's sulfate. Now there is an SO3, and that's called sulfite. Again, be careful on the endings. Okay, our next example is potassium and perchlorate. We're going to write out those ions. Potassium's group 1, so it is a +1 charge. Perchlorate is in column 1 on the polyatomic ion sheet. It's a ClO4-. And that's towards the bottom of that column. Again, we're not worried about those charges. So we have a +1 and a -1. So what are we going to drop next to the potassium? What are we going to drop next to the perchlorate? Well, we're going to be dropping a 1 and a 1. So does that need reduced? A 1 and a 1 does not reduce, so no, it does not need reduced. Therefore, doesn't need parentheses around the polyatomic ion. What do we have next to the perchlorate ion? It's a 1. In math, if you only have one grouping of something, you don't have to put parentheses around it. So we're not going to put parentheses around this one either. We're just going to write it out as KClO4. Naming it, does the cation need a Roman numeral? Potassium's in group 1, so it's not part of our little section over here. So it does not need a Roman numeral, so we're just going to name it as potassium. And then the cation ClO4 is going to be the perchlorate ion, so we're just going to name it as perchlorate. So the name of this is called potassium perchlorate. Our next example is calcium hydroxide. I will tell you this right now, that hydroxide is one of the most commonly missed ones because I think sometimes you guys forget to put parentheses around it when needed because it doesn't have any subscripts. So our ions are Ca+2, calcium's in group 2. Hydroxide is in the first column on the polyatomic ion side. It's about halfway down. And it's an OH-1. Again, we're not going to worry about those charges. Remember, if there's no number next to a charge, it is understood to be 1. So we need to switch and drop something on those red lines, and those are the only ones that we can reduce. So what comes down next to the calcium? Well, that's going to be a 1. We won't write that in our final formula. And then next to the hydroxide will be a 2. Can you reduce a 1 and a 2? No, you can't. However, this is a polyatomic ion. Hydroxide's polyatomic. And notice we dropped a 2 next to it. So does it need parentheses around it? Absolutely. We have more than one grouping of that hydroxide, so we need parentheses around it. And we're going to have those parentheses when we write our final formula. So we're going to write it as calcium, Ca, parenthesis, OH, parenthesis, 2. We go to name it. We need to know, does our cation need a Roman numeral? Well, where is calcium located? Calcium's located in group 2. It's not part of our section that needs Roman numerals. So we are not going to give it a Roman numeral. It's simply named calcium. Then we name the anion, which is the OH-1, and that is the hydroxide ion, so it's called calcium hydroxide. We're going to skip the next example because it's the same one we just did, just from the ions to the formula itself. So let's go over to the Fe+2 and the ClO-. So let's write our ions down next to each other. We have our Fe+2, ClO-. Again, we can forget about those charges. We're not worried about those. But keep in mind that next to the minus sign, that would be a 1. It's understood to be there. We're going to switch and drop. So what comes down next to the iron would be a 1. Next to the ClO is a 2. Does that get reduced? A 1 and 2 cannot be reduced. So we can simply write it as it is, but we need to ask one more question yet. Does the ClO need a Roman numeral? Not Roman numeral, but a parenthesis. What do we have next to the ClO? We have a 2. Just like in math class again, if you have more than one grouping, you put it in parentheses. So yes, this will need parentheses around the ClO. Now we can write our formula. You have an iron, Fe, parentheses ClO, parentheses 2. Now we need to name it. Always starting with your cation and asking the question, does it deserve a Roman numeral? By now you should know where iron is located and that it is in the area where we need a Roman numeral. So it will get a Roman numeral. The original charge on the iron was a +2, so it gets a Roman numeral 2. Now we need to know what ClO- was. We have to find that on our ion sheet. If you look down in the -1 section, which is the first column, go all the way down and you'll see, keep going, you'll see a ClO-. Now what is the name of that? That ion is called hypochlorite. hypochlorite. So when we go to name our anion, we need to name it according to the correct polyatomic ion, and that's hypochlorite. We have two more examples, and we're going to go the opposite way now. We have a formula, and we need to name it. We're just going to start by naming first the cation, and doesn't need a Roman numeral. We'll start with nickel, and knowing its location doesn't need a Roman numeral. Yes, we know it does. For now, we're going to just put it in and leave a blank spot for the parentheses. We'll leave the parentheses there, but just leave them blank until we can go back and figure out whether it was reduced or not. Now we can name our anion. PO3, if you look over in the third column, you'll see ASO4 minus 3, PO4 minus 3, and PO3 minus 3. This is the PO3 minus 3. It is called phosphite. So we're going to put phosphite down there. Now we need to figure out, was this reduced or not? Because we need to know the original charge on the nickel. Right now we're seeing a 3-to-4 ratio. Was this reduced? What was the original charge on that PO3? Again, look on your ion sheet, last column. That was a -3, which means if that were a -3 originally, then I should see a 3 down here, and I do. So was it reduced? No. I should see a 3 next to the nickel, and I do see a 3 next to the nickel, which means, since it wasn't reduced, that the original charge on the nickel was a +4. So this is going to be nickel 4 phosphite. Our last example is NiPO3. Again, we already know that nickel does deserve a Roman numeral from the last example. So we're going to leave that space for inside the parentheses for a Roman numeral. We are still using a PO3 ion, which is the phosphite ion. We're going to name that as phosphite. Now, what ratio are we seeing between the nickel and the phosphite? Right now, we are seeing a 1-to-1 ratio, not a 1-to-3. That 3 is part of the phosphite ion. That is part of the polyatomic ion. So right now we're seeing 1 nickel for every 1 phosphite. Was it reduced? What's the original charge on the phosphite? You already know it's a -3. So what should I see next to the nickel? I should see a 3, and I don't. What I'm seeing is a 1. So yes, this was reduced. And I should see a 3 down here, and I don't. A 1-to-1 ratio is the same as a 3-to-3. It was reduced, which means the original charge on the nickel was a +3. So this is nickel 3 phosphite. You can also double check the math to make sure that you have something that's neutral. 1 at a +3 and 1 at a -3 gives you something that's neutral. Overall, the crystal has to be neutral. All right, so that's all for the examples today. So just like the last video you had, here are 6 examples. These all involve polyatomic ions. I want you to find a space somewhere in either one of your packets and answer the 6 questions. For the first 3, you're going to write formulas for them. For the last 3, you're going to name them. And again, keep in mind, when you're naming in 4, 5, and 6, does that cation deserve a Roman numeral? Pause and go ahead and answer those, and then you'll be done with the video for today. Thanks for listening.